Welcome friends to my YouTube channel. Now on yesterday's lecture I have discussed about the moment of inertia of a solid cylinder, okay, about its own axis of symmetry, and I also told about an axis that passing through the center of gravity and perpendicular to the length of the cylinder. Now in this today's lecture I shall going to discuss the moment of inertia of a say elliptic disc, you can say, that is moment of inertia of a elliptic disc. Okay, previously I discussed about thin rod, circular ring, circular disc, solid cylinder. Now today's lecture is on elliptic disc. Okay, about say any of its principal axis, about any of its principal axis. Now we all know that if this is a ellipse, okay, this is the major axis and this is the minor axis. Okay, say x o x dashed, this is major axis, that is 2a, and say y o y dash, this is minor axis of length 2b. We all know, and the equation of such a ellipse whose major axis is 2a and minor axis is 2b, you all know that x square by a square plus y square by b square, this is equal to 1. This is the equation of an ellipse. Now if we want to find out the moment of inertia about any of its principal axis, just say about y o y dash axis. Okay, that is about the minor axis. Okay, so just take a strip, okay, at a distance x from O, and if we take this strip at a distance x, that means the width of the strip is dx, say, and this length is equal to the 2y. This length is 2y. So take a strip of width dx at a distance x from minor axis. So length of the strip is 2y. Okay, so length of the strip is 2y and width is dx. Fine. So if rho is the mass per unit area, so what will be the mass of the strip? Mass of strip. So rho is the mass per unit area, so what will be the area? Length into breadth or width, that is 2y into dx. Fine. Now rho into 2y into dx. Fine. Now what would be the moment of inertia due to the entire disc about the minor axis? Now just see, the axis is taken through the midpoint. That means if this is 2a, this is minus a, this is plus a. Okay, since the axis is passing through the midpoint, this is minus a and this is plus a because the total is 2a. So the moment of inertia of the entire elliptic disc about the minor axis, that is simply we have to integrate this minus a to plus a, rho into 2y into dx. Fine, because we have considered the strip along x-axis, that means major axis, so the limit will be minus a to plus a. If we take it along this axis, then the limit will change from minus b to plus b, no matter. Now we have to replace here. How? That is, the equation of an ellipse is x square by a square plus y square by b square is 1. So what will be my y square by b square? That is simply a square minus x square by a square. So what will be my y? That is simply b by a into square root a square minus x square. Okay, so this is the, so we have to put this value, that is we have to convert this y variable into x, so we have converted it. So okay, now again the parametric equation of an ellipse is x equals to a sine theta and y, this is equals to a cos theta. Okay, this is the parametric equation, x equal to a cos theta and y equal x equal to a sine theta, y equal to a cos theta. Okay, fine. Y equal to b cos theta. So if we assume x equal to a sine theta, okay, and the limit is minus a, so when x is minus a, that means sine theta is minus 1, that means theta is minus pi by 2. Okay, and when x tends to plus a, the limit theta will changes from plus pi by 2. Okay, so here we have assumed x equals to a sine theta. Okay, only this will require, this will not require. Okay, so when x is minus a, theta is minus pi by 2. When x is plus a, theta equals to plus pi by 2. So if we substitute these values b by a into root a square minus a square, then what happens? The integration limit will be minus pi by 2 to plus pi by 2. Okay, rho 2, this is simply b by a to root a square minus a square sine square theta, and dx is what? A cos theta d theta. So simply this is minus pi by 2 to plus pi by 2, 2 rho b by a square minus a square sine square theta means a square cos square theta, that root is a cos theta. Okay, and this is also what? A cos theta d theta. Okay, okay, b by a into square root a square minus a square sine square theta means sorry, there will be x square term because this is the mass and this is the distance square, so we have to put here x square, that means a square sine square theta, there will be a term. Okay, sorry, I made a mistake because this is the mass, so this is the distance square, so we have to put x square, that means this term. So what would be the result? This is a cancels, 2 rho b a cube minus pi by 2 to plus pi by 2, this is sine square theta cos square theta d theta. Okay, now we have to perform this integration. Okay, okay, so I, this is simply 2 rho b a cube, this is simply minus pi by 2 to plus pi by 2 sine square theta cos square theta d theta. Okay, so if we take here 4, then you multiply here by 4, so rho b a cube by 2, okay, minus pi by 2 to plus pi by 2, this is 2 sine theta cos theta whole square, that means sine 2 theta whole square, that means you can write sine square 2 theta d theta. Fine, 2 sine theta cos theta whole square, that means sine 2 theta whole square sine square 2 theta. So again you have to put here 2 and here 2. Okay, so rho b a cube by 4, this is simply minus pi by 2 to plus pi by 2, this is 2 sine square 2 theta, that means 2 sine square theta means 1 minus cos 2 theta, so here 1 minus cos 2 into 2 theta, that means 4 theta. Okay, we use that formula, 2 sine square theta is what? 1 minus cos 2 theta. Okay, So this is 1 minus cos 4 theta, because here theta is 2 theta. Fine. Now what will be the result? Rho b a cube by 4. This is d theta, that is theta from pi by 2 minus pi by 2, that is pi, and this is 0, because integration of cos 4 theta d theta means sin 4 theta by 4, and sin n pi is 0, that means this term vanishes. Okay, integration cos mx dx means sin mx by m, and sin n pi is 0. Okay, that we all know. Cos mx dx means sin mx by m. Okay, and sin n pi is always 0. So this is the result. So what we have found, rho b pi rho b a cube by 4. Now we all know that the area of an ellipse is a pi ab into a square by 4. Now this is the area of the ellipse, because mass per unit area is rho, and what is the area? Pi ab. So pi rho ab represents the total mass. Okay, so ma squared by 4. So the result is m into a square by 4. Okay, so the moment of inertia, if we calculate about the minor axis, that is ma square by 4. Similarly, if we do the reverse about x axis, we get the result mb square by 4. So what will be the moment of inertia of the elliptic disc about an axis passing through the center and perpendicular to the plane of the disc? That we know from perpendicular axis theorem. This is the ellipse, this is the major axis, and this is, now what will be the moment of inertia about an axis that is perpendicular to this? Okay, this axis that is perpendicular to the plane of the disc, that we know from perpendicular axis theorem, that is ix plus iy simply m by 4 a square plus b square. So this is the result. Okay, so this is the simplest thing, that is calculating the moment of inertia of an elliptic disc. Okay, so this is fine. Okay, now say, take the example of diatomic molecule about an axis passing through the center of gravity. Okay, that is passing through the center of gravity. So a diatomic molecule consists of two atoms, say one of mass m1 and another is mass m2, say. Okay, so this is say from r1 and this is r2. These are not equal, mind it. Center of mass always lies closer to heavier body. Okay, so this is not equal, that is, say m1 is the mass of the first molecule and m2 is the second molecule, and their distance from the center of gravity is r1 and r2. Okay, fine. That means you take this r equal to r1 plus r2, that means r1 plus r2 means the distance between the two molecules. Okay, distance between two molecules. Fine. Now what will be the moment of inertia of m1 about this axis? If you take it I1, that is m1 r1 square. Fine. And what will be the moment of inertia of this about this axis? That is simply m2 r2 square, that we already know. Okay, moment of inertia of m1 about this axis m1 r1 square, and about this axis m2 r2 square. Now we all know from the center of mass theory that M1R1 is always M2 R2. Fine, that we know. So what will be my R2? My R2 will be M1R1 by M2. Now R, this is equals to R1 plus R2. So R1 plus R1 into M1 by M2. That means R1 into 1 plus M1 by M2. So what will be my R1? My R1 will be M2R by M1 plus M2. Okay. So what will be the moment of from center of mass theory? We know this M1R1 equal to M2R2. So put R2 equal to M1R1 by M2. Now R equal to R1 plus R2. Substitute the value of R2. We get R1 in terms of R. So similarly, you need not require to derive both this. Similarly, you can write R2 M1R by M1 plus M2. Okay, R1 and R2 is necessary. Okay, so what will be the total moment of inertia of the diatomic molecule about the axis of rotation? M1R1 square plus M2R2 square, because we require the values of R1 and R2 in terms of R. Now substitute this. M1, this is R1 square, means M2 square R square by M1 plus M2 whole square, plus M2 into M1 square R square by M1 plus M2 whole square. Okay, fine. Now R square we take common, and we also take M1 M2 common, so that means M1 plus M2 by M1 plus M2 whole square. This cancels, so R square into M1 M2 by M1 plus M2. This is this is known as mu R square, where mu is what? M1 M2 by M1 plus M2. That is not the individual mass but the reduced mass of the system. That is, we can express the entire mass of the system in terms of mu. Okay, reduced mass of the system, M1 M2 by M1 plus M2. So this is the expression of moment of inertia of a diatomic molecule about about an axis passing through the center of gravity. Okay, that is simply mu R square. Okay, so what are the basic examples of diatomic molecule? You all know O2, N2, H2, etc. That is AR, in a word AR. Okay, so in our today's lecture we have calculated the moment of inertia of an elliptic disc and a diatomic molecule. Okay, so in our next class I shall going to discuss the triangular lamina, spherical shells and spheres, these things. Okay, so if you don't subscribe my channel, then kindly subscribe it to get latest videos on physics. So the link of this video will be given in the description box. Okay, thank you.